So we have a stationary box P on a rough surface, and then another box Q is placed on top of box P. The forces F1 is 100 Newton and F2 is 25 Newton are applied to box P. So the mass of block P is 5 kg and the mass of box Q is 2 kg. So I want to calculate the normal force on box Q, normal force on box P, and the static frictional force on box P and determine its directions. So in order to calculate the normal force, we are going to follow the problem-solving strategy in order to apply Newton's law. First, we are going to draw the FPD for the respective object, and then we are going to choose the axis. Then we do resolving or break down the forces into x and y component. Then last step, only we apply the Newton's law of motions. Depends on the conditions of the objects, whether the object is stationary or move with constant velocity, then we are going to apply Newton's first law. If the object is accelerate, then we are going to apply Newton's second law. So if I refer to the keywords, the box P is stationary, so I know that I'm going to apply, means that I'm going to apply Newton's first law, whereby the total force will equal to 0. So we solve the question one by one. So in order to find for the normal force on box Q, we are going to start with the FPD for object Q. So for this object Q, I'm going to have weight acting downwards. Since Q is in contact with P, so they are going to have a normal force acting upward. And Q. So let this one X my x-axis, this is my y-axis. Then I can see obviously the normal force on box Q is acting upward. The weight of box Q is acting downward. Since the system is stationary, so I'm going to apply Newton's first law. Summation force for component y is equal to 0. So I'm going to have NQ minus weight Q equal to 0. So rearrange the equations. The normal force on box Q will equal to the weight of box Q. So how we calculate the weight? Weight will be the mass of box Q multiplied G. So I'm going to have the mass of box Q is 2 kg, the G is 9.81. So we will get a normal force acting on box Q will be 19.62 Newton. Okay, done question A, then we move on to question B. For question B, I need to calculate the normal force on box Q. So the first step, I need to draw the FPD for box P. So for box P, we are going to have weight, box P acting downwards, WP, and since Q is acting on box P, so we are going to have weight for box Q as well, WQ. Okay. Then since P is in contact with the surface, so we are going to have normal force acting upwards. And P. Then there are two external apply force acting on box P. So we redraw the apply force. So F1 and then another one F2 pointing leftward. So since the surface is rough, it means that we are going to have static friction force acting on object P. So if we refer to the apply force given, our F1 is greater than F2. So it means that our box P will tends to move rightwards. Static friction force will acting leftward, opposite to the tendency of motion. So this will be our Fs. So in order to apply the Newton's law to calculate the normal force on box P, I need to choose the axis and then I need to resolve or break down the forces into x and y component. So I treat this one as my x-axis and here as my y-axis. Okay, after I put the axis, I can see obviously my normal force for box P is pointing upward, weight is pointing downwards, F2 and Fs is pointing leftwards. Anyhow, F1 is acting at an angle 30 degree. So I need to break down F1 into its perpendicular component X and also component Y. So when I break down F1, I'm going to have component X, F1 will be F1 cos 30, and then I have a component Y for F1, which is F1 sine 30. Okay, so I already break down F1 into its perpendicular component. So to calculate the normal force acting on box P, I need to consider all the forces lie along the y-axis. Okay, I need to consider all the forces that lie along the y-axis. So I'm going to have total force along the y-axis equal to 0. So I have MP positive because it's upward and F1 sine 30 also upward. So plus with F1 sine 30 minus the weight. Why minus? Because weight is acting downwards, minus WQ minus WP equal to 0. Then I can then put in the value. So F1 is 100 sine 30. Weight Q is the mass of the Q, mass of box Q, 2 times 9.81 minus weight P will be the mass of box P, 5 kg times 9.81 equal to 0. Then I can solve for NP. So the normal force on box P will be 18.67 Newton. Okay. So done with question B. Question C, I want to calculate the static friction force on box P and determine its directions. So if we refer to the free body diagram we draw, so the friction force is acting along the horizontally x-axis. In order to calculate the Fs, I'm going to consider all the forces acting along the x-axis. Okay. Again, since the object is stationary, so I'm going to apply Newton's first law. So summation force along the component x equal to 0. So along the component x, I have F1 cos 30 pointing rightwards. I have F2 and also the static friction force pointing leftward. So I'm going to have F1 cos 30 minus F2 minus Fs equal to 0. So put in the value. So F1 is 100 cos 30 minus the value of F2 is 25 minus Fs equal to 0. Solve it using calculator, then we will get the static friction will be around 61.60 Newton. How about the directions? The direction of the static friction force is pointing leftwards. So we have solved the question. We have get the normal force on box Q, normal force on box P, and also the static friction force. And the direction is leftwards.